W6WUH, Larry in California. So we're on the home stretch with this transmitter. It will load up normally, make normal power working at 75%. It'll modulate. But listen to this plate tuning capacitor. Hear that? Then there's a real problem right about get this thing over here where I can see it. Right about at the dip point, when the capacitor is right about like this, the thing will arc. And if it starts to arc, you can't dip it anymore. And of course there's you know, an arc going between these plates. Now this is a 2-section plate tuning capacitor. Both sections are 250 microfarad. Both are identical. So let's look at this one that doesn't arc and try to look at the plate spacing here. And you see that it's fairly even and symmetrical, and there's no arcing in this section. Now look at this section, which it does have arcing, and let's look at it from this end over here. Look how close these plates are together. They're not. Look at this one. Let me get a pointer here. Can't find my own pointer in them. Okay, let's look at this one right here. Do you see how small the gap is on one side and how fat it is on the other? And the one next to it, and the one next to it, and the one next to it, and the one next to it. Not symmetrical at all. All of the plates in this capacitor are asymmetrical. There's not a single one that's dead center in the middle like they are in this one. These plates are pretty much in the middle of the groove, and that's where you want it, baby, in the groove. But over here, they're all canted over to the right. Now I'm going to take my little handy dandy feeler gauge and measure these gaps, and we'll get some numbers on it. But you can see, if you look, let me get over here where we can see this thing again. Yeah, sorry. Very hard to photograph in any circumstances, and handheld doesn't make it easier. And I think you can see where there's a discolored plate there. 1, 2, 3 over from the right. You can see that that plate is discolored, and that's because it's been arcing. And so the question is going to be, how the hell are we going to fix this? These plates are there's one. Let's get the screwdriver again. Get down in here. This one, where's the screwdriver? This one right here. And this one, you can see the erosion from the arcing on there and the discolored plates. And these two over here, same deal. So, my problem now, I'm going to fire this thing up and let you see it arc. But my problem now is to figure out how to fix this. maybe here's a method here. There's a common shaft for the rotating half. That's all one piece of metal, and you can't do anything unless you want to get in there with pliers and start bending plates. But I see that there is a physical coupling between the bottom halves right here, and I bet if I stick a washer in there that I can move the bottom section to the right in the image, this direction, and change the centering of the plates. So I might have to do that. I might try to loosen everything up and see if I can wiggle it around and change it any. But I don't want to change the one on the left. It's just fine, thank you. But anyway, that's the problem. It's a weird one, but it has to be dealt with. Taking and just tweaking the leaves on the capacitor here a little bit might prove to be the easy solution. I'm going to pull this shaft out and see if that is what's making this noise. But it sounds like it's coming from the capacitor. On the other shaft that went through the bezel, when I pulled it out, I cleaned it up with emery cloth because it was rusty. Got it shiny and smooth and lubricated, and I'll do the same with this one. And at the same time, I'll be able to twist this capacitor without that shaft in there and see if that's what's making the noise. But it should not do that. Okay, I'm just going to show you this briefly because it's getting worse, but oops. Well, now it doesn't want to do it. There you go. So that's going to destroy that capacitor quickly, and going to do other damage here. So that's what we got to fix. Since I didn't have much to lose, I took this little screwdriver right here and got it down in between the leaves of this capacitor and just evened up the spacing as best I could. I wedged, I twisted, I bent, I did whatever I could to try to even this up. And you can see that it's not a real precise, but here's one that was clearly arcing badly, and now you see that the separation is pretty even. Before it was extremely close. You probably couldn't have put a piece of paper between there. I never did measure it, but I did this on both sides of the capacitor. Let's see if we can see this other side. And if you listen to it as I rotate it now, you can hear that it's not dragging. So somewhere in the rotation it was literally dragging on another plate. So that's gone. What I'm going to do now is take some very fine emery cloth. I think I have 400 or 600 grit emery cloth, and I'm going to try to polish these plates, particularly the ones that have been arcing and have rough edges on it, and get those as smooth and bright as I can. And then I'll put the shaft back in here and we'll try it again. I got a feeling our problem will go away. I'll probably get in here with something. I think I have some pipe cleaners that somebody gave me, and I think I'll dip those in deoxit and try to get in there and clean that better. I don't want to move the position of those plates again, but I do want to get those plates cleaner. And I'm going to polish up these plates and get the arc roughness off of them, and if I have to reset the spacing here again, I will, but I think this will probably cure the problem. Okay, here's that rusty shaft, and you can see now that it perfectly good. Feels very smooth, rusts off it. And how did I do that? It took me about a minute. I had some 180 grit, what do you call it, I can't say anything, but whatever the fuck this stuff's called, emery cloth, and just wrapped it up in there, and maybe I used a 220, I guess I used a 220. I just put it inside there and pushed it in and out, twisted it a little bit, cleaned right up. The grit isn't real that important, but you don't want anything that's real fine. But on these things, I'm going to use the finest stuff I have. I think I'm going to start with maybe 220 or 320, and then use my my 400 or my 600. You got to clean this scrupulously when you get done. I think that this emery cloth stuff I don't know why it should be conductive. I guess they tell you not to use it on the commutators of generators. I guess it gets stuck in there and makes sparking. But anyway, I'll clean it out real good, then it'll be fine. Alright, clean the shaft, put a little tri-flow on it. Nice and smooth. There you go. Okay, we removed the two screws holding on the tank coil. This one here and this one here, and just pushed it aside. It's got all these taps soldered onto it for 40, 20, 15, 10. So, or at least 40, 20, 15. So you can't really pull it out without a lot of work, but you can push it over so that you got some more room to work. So that's what I'm doing here now. And I'm going to get in here with my emery cloth, polish up the inner the hoozies of the plates of the capacitor, and we'll see and clean that up, see what we get. So one question here is the fact that there's some corrosion on the internal faces of these plates one of the things that led to arcing over there. We know that the gap was too small, and the voltage rating is absolutely dependent on the gap, the air gap. But these had some green corrosion on them, and I'm getting in there with a folded piece of emery cloth and trying to polish them up. And I've been working on this for a couple of minutes, and this is what we've got. I wouldn't call this beautiful by any means. But that's the reality of this thing from sitting wherever it was stored. I don't know, maybe in a damp shed or a damp garage or something, but dirt and moisture are not kind to some metals. The brass stuff in here has been the most susceptible to turning green, and unfortunately some of these sockets are riveted in, I think with brass rivets that seem to be a little green underneath, and I've checked them with the ohm meter and tried to wiggle them and make sure that they're solid, but this is what you get when you get a really cheap transmitter. So I'm going to keep working on this and see what I can do. I'm going to try to scrape and polish and then go through and clean out all the abrasives and crud, and then we'll try it. Okay, here I have a piece of 220 emery cloth folded up in enough layers so there's a tight fit between the plates, and I'm going like this and turning the capacitor at the same time. So that's how I'm doing it. Well, I've never used pipe cleaners before, but here I'm using a folded over, wet pipe cleaner to get between these plates and clean out the abrasive and the metal that I have been polishing there. So that's what I'm doing to get these clean. I've got the tank coil flopped over toward me to make space on the back side here, or the inside, so that I can get in here with my what do you call it? Emery cloth, and clean the fixed side of these capacitors, because they have to be clean and free of arc damage and corrosion as well. So I'm going to do the same thing that I did with on the rotating plates. I will do to the fixed plates here and clean them up with the emery cloth, and then go through and clean out the residue. Then I'll shoot it all with deoxit, dry it off, and we'll see what we get. Well, here we go. We're just going to try this transmitter tuning now, and I think we'll find that it is now dipping just like it should. So no arcing through the tuning range. Dipping smoothly, no arcing, just what we want. Should be able to load it up to 450 mils. It's tuning much more smoothly now than it did. The loading is quite a bit different now from what it was. Let's see. Power's not right though. Well, let's take a look at the grid drive. Run the grid drive up where it ought to be. Back and look at the plate current. This is where it was loading before. Okay, there's the peak power. And there's the dip. It's also now dipping about where it should. There we go. Not making as much power as it ought to. I'm not quite sure what's going on here.